Welcome to Math with Mrs. Seeley. Let's get started on this 2022 free response question number 2. For this question, we're given this graph and told that we have two functions, f of x and g of x, that intersect at x equals negative 2, as we can clearly see, and some other point b. A part says to find the area of the region enclosed by the two curves, or the two graphs. When you're trying to find the area of a region, you know that it's the top curve minus your bottom curve. So we need to come up here and first determine which curve is which. This ln, or this natural log curve, is actually this right here. But if you're not certain of that, maybe think about this one, because that's a polynomial, x to the fourth, and it's got lots of twists and turns in it. So this bottom curve is your g of x, and the top curve is the natural log function. So we need to find the area. So the area is going to be to integrate the top curve, which is f of x, minus the bottom curve, which is g of x, dx. Our limits of integration are obviously from negative 2, but we need to find that top limit, and that's going to happen by finding the intersection point of the two curves. So go to your calculator, type in your two functions, f of x and g of x, and then to find the intersection, if you'll recall, you go to second, calculate, or some people think of it as blue, trace, and you want option number 5 because that's your intersect option. And then you're going to hit enter to tag the first curve, enter to tag the second curve, and enter to get the solution. The place that those two curves intersect is the point 0.782, and I need that to get my top limit of integration. If you found that and knew to find that, give yourself your first of the 9 points this essay question is worth. Then you're going to go put this into your calculator, and you know the drill. Use your Math 9 option to plug those in, and that's going to give me 3.604. That's going to net you your second point of this essay question. All right, let's look at part B. Part B says from negative 2 to b, which we now know is the 0.782, let b, or h of x, be this vertical distance between the graphs of f and g. Is that vertical distance h of x increasing or decreasing at x equals negative 0.5? And then we're going to give a reason for our answer. All right, so they're asking if it's increasing or decreasing. So they're asking us to consider the rate of movement, which is derivative. So if I know that h of x is the distance between those graphs, that means that h of x is f of x minus g of x, the distance between those. And they asked me to consider if this rate is increasing or decreasing. So therefore, I need to consider the derivative. So since they're asking about a rate, I need to look at the derivative, because recall, the derivative is a rate of change. So I'm looking at this right here, that rate of change between those two lines. If you knew to consider that as a rate of change, give yourself another one of your points. We want to do this at negative 0.5, so then we want to find h prime of x at negative 0.5, which is simply going to be to take the two functions, subtract them at your negative 0.5. So go to your calculator and do that with your derivative. You're going to use your Math 8, which is your derivative function. When we do that, we get the value of negative 0.599. And so since h prime of negative 0.5 is negative, that means that h is decreasing at x equals negative 0.5. That looks like his, so let's make that say h is. If you found out that that was negative and decreasing, give yourself another point. That way you're telling them it's decreasing and you're giving them the reason. It's because the derivative there is negative. All right, so let's take a look at C part. C part says the region enclosed by the graphs f and g is the base of a solid. Cross sections are perpendicular to the x-axis are squares. We want to find volume. You guys should be familiar that to find volume, you're going to integrate area. This particular figure is a square, and you guys know that the area of a square is side squared. So, therefore, we're going to find the volume by integrating from negative 2 to that 0.782 of the square, which is side squared. The side is, of course, that top curve minus that bottom curve, which is f of x minus g of x quantity squared dx. If you knew to set up your integral to take the side of that square squared, give yourself a point, then you're going to put this into your calculator, and when you do, you're going to get 5.340. And again, you're going to use Math 9, your integrate function, to do that on your calculator. To get that answer of 5.340, give yourself another point. All right, let's look at D part. This one may be the trickiest of all of the A, B, and C, D. It says a vertical line in the XY plane travels from left to right along the base of that solid, that square solid in part C. The vertical line is moving at a constant rate of 7 units per second. We want to find the rate of change of the area. So they want us to find the rate of change of the area of that cross section with respect to time when the vertical line is at x equals negative 0.05. So they want us to find the rate of change of area. That means they're asking us to find the derivative. So we want the derivative of area. So we want derivative with respect to time of the area from the part C. We know that the area of part C, remember that was the side of a square, and it was f of x minus g of x. It was that side squared. So that was the area from part C that they want me to find the rate of change or the derivative of. So to do that, I'm going to say that that's equal to the derivative of area, dA dt, with respect to time. But here it might be the little bit tricky part. We are also looking at with respect to time, but we've got this vertical x equals line, so we're going to need to chain dx dt. That's the rate of that vertical line, and we are told that that vertical line is moving at a constant rate of 7. So that's what your dx dt is. It's going to be 7 that we're going to need to multiply. So then you're going to go to your calculator and calculate the derivative of this area function, and then you're at negative 0.5. So we're going to find the derivative at negative 0.5, and then we're going to need to multiply by that 7 right there. Go to your calculator and use your Math 8 function to find the derivative at the negative 0.5, and because that is a pretty crazy type in, I went ahead and wrote it out so that you can see exactly what you need to be putting into your calculator. So Math 8, the derivative, the calculator automatically opens up that yellow. You're going to open up another parentheses because that parentheses with that parentheses, quantity squared, has to be around f of x minus g of x. Then you're going to evaluate it at negative 0.5. When you do, you're going to get your answer that is then going to be multiplied by 7 to get a final answer of negative 9.272. When you do this, I actually have this value, so it might be helpful to you. When you did this on the calculator, you get negative 1.32455 and then some, but you're going to take that and times it by 7 to get your final answer. I thought that might be helpful for you. As far as your points are concerned on this one, if you knew to take the derivative of that and that chain on it to consider multiplying by that rate of movement of that line of 7, give yourself a point. And then to get your final answer, give yourself your other point. I hope you found this helpful in preparing for your AP exam. If you did, please like, comment, and subscribe to the channel. Be sure to check out other AP Calculus essay question explanations as well as calculus tutorial videos on the channel. See you next time.